so this is going to page 34 when we're done. So we're going to look at rational functions and our zeros. All right, so again, to recall, said this a few times, rational function is just a ratio, think fractions, denominator has to have a variable in it, all right? In 1.5, which has been a while because of all the crazy testing we've had, we did polynomial inequalities, okay, where we made a number line and we tested values. So we're basically doing that for rationals, but rationals have some additional properties that we have to take into account as we go through that, okay? So the things that are important to remember for rationals as we go through this is that when we're doing this, we're looking at the rational function that have no factors in common. So if we have no factors in common, the numerator and denominator don't have anything in common, what have we already found? Asymptotes? Not necessarily. What happens when what do we find when we cancel things out? Holes. So we have already found our holes in our point discontinuity if we don't have anything in common. All right, so like basically this comes after that. All right, so then we know that f of x has zeros when g of x equals 0. That's your numerator. And so that is just the zeros of the function. Those come from the numerator. Zeros of the function, and they come from the numerator. All right. If f of x is undefined when h of... All right, so as I was saying, the f of x is undefined when h of x or the denominator is equal to 0. That is your vertical asymptotes, and that is the zeros of the denominator. So we know that. We've already reviewed all that stuff, but just we have two different things that we have to look at for our rationals, okay? And when solving the inequalities with our number lines and our sign charts, you have to identify both the zeros and the undefined values or your vertical asymptotes, okay? We have to do both. So here is our little steps. First of all, we make sure that the inequality has a 0 on the other side. Meaning, that's another way to say, like, basically we're solving, we set it equal to 0, but it's not equal because it's an inequality. So you might have something that looks like this, like x squared, or x to the 4th minus 4x squared is greater than x squared minus 9, something like that, okay? So what I see sometimes is y'all will have that, and you're like, oh, I know how to factor. I'm going to factor out an x squared right here. That's going to give me x squared minus 4, and that's greater than, then I can factor that, x plus 3, x minus 3, and then from there you start to make up math and absolutely nothing makes any sense, okay? 99% of the time, you don't factor unless you have a 0 on one side of the equal sign or inequality sign, whatever, because that kind of factoring and finding zeros right now, that makes absolutely no sense. So this is a big fat no. Sometimes it's good to have written down what not to do, so when you start doing weird things, you can be reminded, don't do that, okay? That's bad, bad, real bad. We make sure that the function, the rational, is a single rational function. I can't have a fraction and then like plus 1 or plus x and it not all be in one. The good news is really all of ours will be all in one fraction because we're not testing, can you do the algebra to get it into one fraction? We're testing, do you understand what to do with the rationals themselves? So that's important, but really it'll happen for us anyway. Then we set the numerator and denominator equal to 0. The g of x gives us our zeros. The h of x gives us our vertical asymptotes. And we got to make sure to factor, and factor legally. That's important as well. Create the sign chart. That's going to be just like what we did for polynomials. Be careful to mark the values where h of x equals 0 so that we never include those values. So when we look at open circles, closed circles, vertical asymptotes are always open circles. Okay, we'll talk about why in just a minute. Then we test the values like we did with polynomials to see which if the intervals are positive or negative. we interpret the sign chart to answer the given inequality. And be sure to write your answer in interval notation and think about the endpoints. And if you do your sign, if you make your number line right, you don't have to think too hard about them. It'll kind of be done for you. Right? So let's go through these steps with some of the stuff we have here. All right. Example 1. It's already factored for me. That's great. So then I got to get from the numerator, I'm getting my zeros. I have 1 0 and it's at x equals 2. Right? From the denominator, I'm getting my vertical asymptotes, and I have 2 of those, one at x equals -6 and one at x equals 3. Do we all agree with that? Okay, that's something that we reviewed, something that we know. These are our zeros and our vertical asymptotes. We good? So now I make my number line. And I put all 3 of those things on the number line from least to greatest. So -6, 2, and 3. Now I'm going to put my open and closed circles. Your vertical asymptotes, always open. So -6 is open and 3 is open. Your zeros are dependent upon that inequality sign, whether it's included or not. Since that has the line underneath it, this is a closed circle. Okay, so that will help me with my answers in the end. I don't have to overthink anything. Okay. All right, so now we're going to test values just like we did for polynomials. So somewhere between -∞ and -6, let's go with -7. -7 minus 2 is a negative number. In the denominator, -7 plus 6, negative number. -7 minus 3, negative number. So a negative divided by a negative times a negative overall gives me negative, right? 3 negatives make a negative. You got an odd number of them. Whether you're multiplying or dividing, the same thing happens, right? Everybody with me so far? All right, so then between -6 and 2, what can I choose? 0. If I can choose 0, choose 0, because then that easily is negative, positive, negative, right? And then if I have 2 negatives, overall it becomes positive. Between 2 and 3, I'll have to pick 2.5. It's no big deal, though, because I don't have to actually do the math. 2.5 minus 2 is positive, plus 6 is positive. 2.5 minus 3 would be negative, so that's negative overall. Okay. Then 4 minus 2 is positive, 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 positive overall. Any questions at this point? So now I've made my sign charts. I've got to interpret it based on what I'm looking for. I want this to be greater than or equal to 0, so that's positive and 0. So I'm looking for the positives. The positives are here and here. And whether or not I include the numbers, I know from my open and closed circles that I put there. So here I'm going from -6 to 2. -6 is open, 2 is closed. Then I'm going from 3 to infinity. I never include infinities, and 3 is open. Okay. What questions do you have? Anything? All right, now I'm going to draw some things on here that you don't necessarily have to draw. I just want you to understand how all this works. Now, for rationals, and even for a lot of polynomials, even though I've done these way more than you have, glancing at an equation, I don't necessarily know what it's going to look like, because rationals can be all kinds of crazy things. But this tells me a lot, even if I have no clue from the very beginning. First of all, I know if I think about this number line as my x-axis, I know I have vertical asymptotes here and here, so I can sketch these in. All right. Then, even though I don't have to know it to answer this question, is this function top heavy, bottom heavy, or tied in degree? Bottom heavy. So my horizontal asymptote is at what? Y equals 0. So I'm at y equals 0, and that's basically here. So I have this horizontal asymptote. Then my function, let's see, let me do it in green, I guess, so you can see it. If my function is negative here and I have this asymptote, it's going to have to look like that, because it's going to be below the 0, and I have to hug the asymptote. Then from -6 to 3, I have this 0 where I'm going to cross the x-axis. It's positive, then it's negative. Well, I have to hug the asymptote, and then I have to cross, and then I have to hug that asymptote. And then here, if it's positive the whole time, it's going to have to look like that. So I pretty much have a sketch of my function. Okay, and so when we're looking at, is it positive, negative, what's happening? That's what your graph kind of looks like there. Okay, again, you're not going to have to do that. I just want you to see that it is all connected. And we are going to look at, we've been looking at limits in infinity. We will look at if the function approaches -6 from the left, we're approaching negative infinity. If we approach -6 from the right, we're approaching infinity. Okay, so just some stuff to come. Right now, we just got to be able to get our answers here. Everybody good so far? All right, let's look at 2. On 2, I'm going to have to start by factoring. So I'm going to factor the numerator, x plus 2 times x minus 2 over, and then this will be x and x. The signs are the same. They'll have to both be negative, -5, -5, and that's supposed to be less than 0. Now, I want to clean this up for myself a little bit. I can't cancel anything out. The numerator is going to stay x plus 2 times x minus 2. Denominator, I can make x minus 5 what? Squared and less than 0. Okay, so this is the one I want to use here after I have factored and cleaned it up some, and it will help me. How many zeros am I going to have? 2. I have one at x equals -2 and 2. My vertical asymptotes, I have 1, right, at x equals 5. So once again, I have 3 things that go on my number line. I got a -2, 2, and 5. Vertical asymptotes, always open. This is open. My zeros, are they opened or closed? Open because of that right there, right? I'm not including the zeros, so actually everything is open here. Everybody with me now? That's how we make those decisions. All right, so now I choose numbers. I'm going to pick -3, and I'm putting it into here. So -3 plus 2 is negative. -3 minus 2 is negative. Whatever I put in here, I'm going to square it. So no matter what I put in here, what's the result going to be? Positive. So the denominator is positive no matter what. So this is positive overall. Then from -2 to 2, I'll pick 0. So that'll give me positive, negative, and then the denominator is positive no matter what, negative overall. Between 2 and 5, I can pick 3, so that'll be positive, positive, and then positive. So that's positive overall. I can pick 6, so that'll be positive, positive, positive again. Then I have to identify what I'm actually looking for. I want this when x is less than 0, so that means I want negative here. -2 to 2. I put open circles on both, so it's open. All right, so I want you to notice something here that we have positive, positive here, and 5 is your vertical asymptote, right? So that would mean that it's going to hug the asymptote on either side like that instead of being opposite like it is here. So if you look at this here, this picture, I have this vertical asymptote, and then this is going to infinity, this is going to negative infinity. Let's pretend like that's at -2. All right, so that would mean that in the denominator, I would have an x plus 2, and it would not be squared. Okay, if I have this, then in the denominator, I would have x plus 2, and it would be squared because that's when it's double. So this is what's called togetherness, and we'll get there. But on either side of the asymptote, it can be opposite or it can be going the same. It just depends on what's happening in the equation. Okay, so again, that's just a little FYI for future stuff. It also can help you make sure your sign chart makes sense. But we good? Questions? All right, flip it over. We're going to work through a few of these because different things happen that if we don't talk about them, then sometimes you get there and you're like, this is weird. I don't know what to do. On example 3, can I factor anything? No. All right. So my zeros come from the numerator. Do I have any zeros? No. So then that's the empty set, these squiggly brackets, right? Then vertical asymptotes, I have 1 at x equals 3. So I have one thing on my number line, 3. Is it opened or closed? Open, because it's a vertical asymptote, right? No question there. So now I choose points. I can choose 0 on the left-hand side. Now this doesn't do anything for me. It's a positive 2, so I can really ignore it. If it was a negative 2, the negative matters and I have to pay attention to it, okay? But it's not a negative 2, so it's positive. It doesn't affect anything. So when I put 0 in here, this is negative. If I put 4 in there, it would be positive. That's all I got. And then we want it when it's greater than 0, so that's positive. So we're going from 3 to infinity, and we don't include either one. Okay, we good? On 4, can I factor anything? Yeah. Yes, I can. And it's not going to necessarily help me find the zeros any easier, but I'm going to show you why it actually will help you a little bit in the end. So I can factor this and get 4 times x plus 2 over x plus 5, and that's less than or equal to 0. So if you have even the GCFs factored out, even if they're just numbers, it can help you make more sense of the sign chart. You have to do less calculations in your head. All right, so my zeros, I have 1 at x equals negative 2. My vertical asymptote, I have 1 at x equals negative 5. So I'm going to make a sign chart. I got 2 things on here, negative 5 and negative 2. Is negative 5 opened or closed? Open, because it's a vertical asymptote. Negative 2, opened or closed? Closed, because of this sign right here, right? Everybody okay with those decisions? All right, so now we pick numbers. Let's choose negative 6. So negative 6 in here. See, if I put it in here, I'd have to maybe actually multiply to figure out how it worked. But negative 6 plus 2, that'll be negative. And then negative, so that's positive overall. If I pick negative 3 here, that'll be negative and positive, which makes it negative overall. Then if I pick 0, it'll be positive and positive. That's positive overall. Then we are looking for when the function is less than or equal to 0, that is negative. My negative is right here. So I'm going from negative 5 to negative 2. I have already made the decisions about parentheses and brackets because it is opened and closed. Okay. What questions do you have? Anything? We good? Okay. All right. Then 5 is factored for me. I don't have to factor anything. So my zeros, I have how many zeros? 2. I'm going to have 1 at x equals negative 2 and 1. And my vertical asymptote is at x equals 2. Okay. So on my number line, I have 3 things. I got negative 2, 1, and 2. Is -2 opened or closed? Closed. Is 1 open or closed? Closed. Is 2 open or closed? Open. Okay, because 2 is the vertical asymptote, and my sign implies closed for these. Okay, we're all good? All right, go ahead and do your sign chart. You can do that without me talking you through it. All right. So do you agree with me? I got positive, positive, negative, positive. Okay. Any questions on that? All right. So then I am looking for when the function is greater than or equal to. So I'm looking for the positives here. Okay. There are my 3 little positive parts. Because I get to include 2, I can go all the way from -infinity to 1. If that was an open symbol, then I'd have to go from -infinity to -2, skip over -2, and I'd have to have 2 different ones here. But I include the whole thing, like so. Then I start back over at 2 and go to infinity. Okay. Any questions? All right, so let's just talk a little bit more about this one just because we can. We have a vertical asymptote right here, right? And again, you don't necessarily have to draw this stuff in, just think with me. This function is top heavy. Does it have a slant asymptote? No, because it's not top heavy by 1, it's top heavy by 2, right? And so I'd really have x squared over x, x cubed over x. So my asymptote would be y equals x squared. This is where I would have a parabolic asymptote, right? You won't have to draw any of these or even recognize them with pictures. I'm just telling you, even knowing that much, you really could sketch this. So that means I know, since it's starting positive, it's going to start up here somewhere. When I come down to this 0 here, it's positive then positive, which means it's tangent, right? It's got to come back up. Then I've got to go back through this to become negative, and then it's got to hug the asymptote over here. So it looks something like that. This one is positive the whole time. I know what the end behavior looks like, so it would have to look something like that. And that's your function. Okay, so even without fully comprehending anything, knowing if it's positive or negative, you know the attributes of other things and what are happening. I don't know what it is, but I know between -2 and 1, I have a relative maximum, which could be important depending on what you're applying this to or whatever. Okay, we good? Questions? All right, example 6. My zeros. What are my zeros? Do I have any? No, I don't here because there's nothing in the numerator, so and there's no variable in the numerator, so it's the empty set. Vertical asymptote, I have 1 at x equals 1. So on my number line, I have one thing at 1. And it's open because it's an asymptote. All right? The numerator is positive, so that's positive no matter what. Denominator is squared, so whatever I put in there, what happens? It's positive. So both sides, no matter what I put in, is positive. Positive and positive, right? Which means when I'm looking for when is that less than or equal to 0, it isn't, so this is no solution. And what this graph would look like, it would look something like this. Okay? where this is my x-axis, so I never cross the x-axis or go below it, and I'm hugging this, both sides of the asymptote going in the same direction. Okay. What questions do you have? Anything? All right. Let's look at this last one. Now here, they give me a picture. They give me a picture, and then I have to answer the same question here. The same kinds of questions. So I have, when is f of x less than or equal to 0? So when is it negative? The function is negative here and here, right? We are talking about y. We are writing about x. So where does the function start being negative? At the right on the other side of that asymptote, right? So it starts at -3, not at negative infinity, because that's the y value. The negative part starts here, but I don't include it because I'm not touching -3 because it's a vertical asymptote. Then it's negative all the way to -1. Because this is less than or equal to 0, I include that -1. Then I start being negative. Oops, oh goodness. I start being negative again at 2. And I'm negative until where? 3. Do I include 2? What do we think? 2 is what kind of thing on my graph? It's a 0. Am I including my zeros here? Yes. 3 is what kind of thing? Asymptote. Do I include my vertical asymptotes? No. Okay. What questions do you have? All right, you work on B and C while I hand out the assignment, and then I will come back and talk about them. Yeah, there's some like a toilet paper up there. Okay, so there are some of you that are kind of frozen and don't know what to write. That's okay. Let's talk about this. When is f of x greater than 0? When is it positive? So it's positive here and here and here, right? So where does it start being positive? What x value? Negative infinity, way out here, right? It starts being negative at negative infinity. I'm not negative, I'm sorry. When does it start being positive is what I meant to say. Starts being positive way out at negative infinity. The function's positive till we get to 3. On the other side of 3, it's negative, and that's an asymptote, so I'm not including that. Then it is positive from -1 to 2. Since this is not closed, these are open as well. Then I'm positive again, starting at 3 and going to infinity. Okay, we okay with that? Yes, ma'am. Open, because this is just greater than 0, not greater than or equal to. Does that make sense? Good question. Anything else? Okay, now this one's a little tricky. Okay. Oh, I'm sorry. Oh, yes. Thank you. Thank you. Yes, this is supposed to be a -3. Thank you. I don't have a clue what I said. Hopefully I said -3, but I didn't write it. So yeah, negative infinity and -3. Thank you. Anything else? All right, so this one's a little tricky because it's kind of hard to see on this graph. If I wanted you to do something like this, I would make the graph way more obvious, okay? But this says f of x is greater than or equal to 1. That's where my horizontal asymptote is. It is very hard to tell on this graph, but it crosses at 6 and goes underneath. And I don't even know on yours if you can even tell, because sometimes the copies are even worse than what I have. I mean, if you really, really look at it, you can tell, but it's not the best. So I'm telling you that so we can write the answer here. So f of x being greater than or equal to 1 it is greater than 1, going from negative infinity to -3 again, and then starting back over at 3 and going to 6. Would I include 6? Yes, because that is actually equal to 1 there. Again, if you had to do that, I would make the graph way more obvious, or also just make sure you understood what you were looking at. Okay. What questions do you have? We good? All right, so you got about 5 minutes left. Make a good use of your time.